out our chi-squared information. So Allie, we're looking at this. You already have this. So pull that out, and we're just going to add to it. I'll leave that up for when Julia walks in, and perfect timing. All right, Julia, while you were gone, we had mostly blanks up here under these 4 columns, and we each were to fill one in, and since you weren't back, we filled yours in for you. So it's just like yesterday, same old, just reviewing. We're not studying that right now. That's chapter 10 stuff. Recall where we are. We're going to do some homework problems, like one of each, and discuss them on Monday, or do them on Monday if we don't have time to do them at home. Then you'll get a study, what do you call it, a worksheet test to do on 10. But we are on 11, so let's go there. All right, tell me some things about the chi-square distribution. Generally, what's its shape, Caleb? Caleb, what's generally the shape of a chi-square distribution? It is skewed, right skewed, that's right. So?
I just said it, I know it wasn't your fault. So you didn't do it on purpose.
Alright, Bailey, let it go. Alright. Alright, Bailey, would you tell me how do we get the degrees of freedom when we are looking up a chi-squared statistic?
You took the number of characteristics of carbon.
Exactly. Alright, so we pretty much talked about how to get the chi-squared, and that was observed, minded, expected, squared, divided by expected for each category. Add them up, and you have your statistic. Alright, we started to actually do a complete test. On the back, we were talking about peanut chocolate candies, not the back, but page 2. And we had a hypothesis going. So, you have that written down. Elena, what was the probability of blue?
0.23.
Alright. What's the probability of orange?
0.23.
Okay. And then what, green?
Yeah, 0.15.
And then,
Yellow is 0.15.
what was it, yellow? And then,
Red is 0.12.
and lastly,
And brown is 0.12.
okay. So all of that's different. All of those come in the null hypothesis. You have to list every category and what you expect. So H sub O was kind of surprising. Julia, H sub A, the alternative hypothesis was what? Right? At least one of the above, I think I called it P sub I,
What is the icing?
is any of these colors. At least one of the above is wrong. Right, so somehow you have to indicate that. You can use my little cute eye, or you can write it out. Alright, then we actually talked about how to, we wrote out the whole calculation for chi-squared, but I didn't ask you to punch it in, and it came out to be 11.37, and that's pretty much where we were yesterday. So, in order to do a test to see which of these hypotheses we will reject or fail to reject, we were going to do a check, and it's not written anymore. It's not written in tin anymore. So it may not surprise you what it is. It is a small stream. What's a small stream? It's Brill. So
There are 2 L's in
I
there.
know we only have one.
That's
Brill. I looked up some other things for Brill. It's a small valley on the moon. It's a small broker stream. It is an acronym for and then there's read it later. So whatever you want to redo, you have to know real.
Alright. Did you say something about the moon?
Yeah, little channels on the moon are called rill.
Huh.
So, and little streams are called rill, but they're both double L's.
Oh.
We have to do a real check, so whatever works for your memory. Random. Do we assume that the peanut-covered M&Ms were packaged randomly? We're assuming they are, that they're colored and then put in a batch and mixed up. What?
What is it? Each of them random, independent, and what does that
Yeah, I'll get to that one.
Because we're checking them before we have each of them set.
Wait, before we what?
You're checking them for the specific problem before we've gone over what L is.
Yeah, we will. I'm teaching it by example. So it's random. We're assuming that the M&Ms went in randomly. As in the bags, are they independent? Does the color proportions of one set affect the color proportions in another set? We think not, but we also know that if we took a sample, it's without replacement, so we have to check the n greater than n, 10n. So how many are in a bag? Do we know how many were in his bag? I think we did. Did we add those up? 46. Somebody added those up. So 46 in the candy factory. I think there's more than 460 candies. So check. All right, this L, Julia, now you can know is large expected values. And guess what large is? Greater than or equal to? Any guesses?
30,
Nope.
10,
100.
Nope.
15,
Nope.
3.
You're closest on 3. All right, so random,
Wait,
independent,
what is
and
greater than 5?
expected values.
Oh.
So we haven't calculated those for this. We're going to do that. Oh yeah, we did. We calculated the expected values. We couldn't have gotten the chi-square without well, number 2 above, we calculated the expected values. We took the number in the bag, 46, and we multiplied it by each of these.
Do we have a photocopy of chart C?
I haven't made one. If I have a chance, I'll run out and make one. All right, so looking back up there, I see 10.58, 6.9, ooh, 5.52. So we just barely made the made L, but we did. You see the expected value, one was really close. Was it red and brown or 5.52? So it was close, but we checked it off. All right. So it's ready. We're ready to do the test. It passed. So we're going to test these hypotheses, and we're going to look up the chi-square value on our chart C.